Did an Earth-skimming meteor bring life to Venus? I'm Tonya Hall, and joining me is Dr. Avi Loeb, member of the President's Council of Advisors on Science and Technology, founding director of the Black Hole Initiative, Frank B. Baird Jr., professor of science at Harvard University, and author of the book Extraterrestrial. Welcome, Dr. Loeb.
Thank you for having me.
There's actually more to your resume than what I mentioned in the introduction, believe it or not. On what types of your projects do you spend most of your time today?
Most of my time is dedicated to the study of black holes. They appear in many environments. This is a very exciting time in the context of studying black holes. The Nobel Prize this year was in physics was given to three people that studied black holes for many decades. And it was also given to the study of black holes a few years ago. So it seems like these are the exciting times of black holes. We can study them with gravitational waves, the ripples that they produce in space-time. And we can also look at them by the radiation that is produced next to them and the shadow that they impart on the radiation behind them. And so there are lots of exciting developments in this field. The other subject that I focus on is the search for life. The Nobel Prize was not yet given to this field, but because we haven't definitely discovered any form of life away from Earth, but it has great potential and there is a huge interest in the public. And so I will have two books coming out next year on this subject. One is a textbook, the other one is a popular level. And I'm also studying ways to detect extraterrestrial life.
A short time ago, we spoke with Dr. Sarah Seeger of MIT about the discovery of phosphine gas in the atmosphere surrounding Venus. What we did not discuss was that an Earth-skimming meteor may have contributed to it being there. Tell us about your research on that.
Right, so Venus is the closest planet in its orbit to the Earth. And another close planet is Mars. So we have this trio, Mars, Venus, and the Earth, that shared very similar conditions early on in the evolution of the solar system. And potentially all three of them could have developed life because we know that it's very likely that Mars had an atmosphere early on and had liquid water on its surface. And similarly, Venus probably had the same conditions. Mars lost its atmosphere and therefore the ability to have liquid water, so everything dried up on the surface of Mars. And Venus just went through a greenhouse effect, and basically the surface of Venus is too hot for life to exist on it. But potentially the clouds of Venus, about 35 miles above ground level, have temperature and pressure similar to those in the lower atmosphere of Earth, so they could potentially support life. And the recent announcement of possibly detecting phosphine in the cloud deck of Venus is quite exciting, although it's being debated now. The data is being reanalyzed, and it's not yet clear that indeed phosphine exists in the atmosphere. Now, these three planets exchange rocks with each other. We know that meteors impact the Earth, and in the process of doing so, every now and then, they could expel a piece of rock material away. And the same process happens at Mars and on Venus. So it's possible that life started on Mars or on Venus and then came to Earth by rocks. However, in order for that to be a likely scenario, life needs to survive on those rocks. And if you have a very violent impact on the surface of a planet, the rock may heat up and basically sterilize all forms of life on it. And so a much gentler process would be for a rock to fly through the atmosphere of a planet and scoop any form of life that may exist in the lower atmosphere. So the idea would be a meteor that doesn't really hit the Earth, but actually skims the Earth, grazes the Earth and just goes through the lower atmosphere of the Earth close enough to the ground to scoop up life, microbial life, bacteria, from the lower Earth's atmosphere, and then deliver it to another planet. So that is an interesting process that we examined.
How long might a microbe have to survive in interplanetary space before arriving at a neighbor planet?
We don't know how long a microbe can survive, but the estimates that were discussed in the literature go up to 100,000 years or so. And it really depends how deeply buried the microbe is. Obviously, if it's on the surface, it might not survive very long because of the bombardment by cosmic rays and the harsh conditions on the surface. But if it's buried deep enough, there is a protective layer that could keep the microbe alive. And we know, for example, that tardigrades, these are small, tiny animals that were brought into space, survived for a week or two. And when they were brought down, they produced healthy embryos, more than half of them. And so potentially one can imagine life surviving in space, even without water and in vacuum. And the only question is for how long? So when we studied the problem, we assumed that 100,000 years is a reasonable time for the survival, as long as the life is not being destroyed when it hitchhikes on top of this rock that passes through the atmosphere. And the idea is that these microbes are tiny astronauts that catch a ride on this spacecraft, this asteroid that goes through the Earth's atmosphere, and then reaches either Venus or Mars, potentially, while still being alive, if that journey takes less than 100,000 years. Of course, you have to keep in mind that it's not enough for it to leave the atmosphere of Earth. It needs to arrive at those targets, those destinations. And for that to happen, there needs to be an intersection of the orbit of that rock with this other planet, which takes time. And so we calculated how many such incidents may have happened over a period of 100,000 years, and found that of older 1 million asteroids could have grazed the Earth atmosphere and arrived at Venus within 100,000 years, the time that a microbe may survive.
I like the term tiny astronauts. If microbes can be transported from Earth to Venus, is it possible then that microbes could be transported from planet to planet via meteor or asteroid in general?
Definitely. This process is called panspermia, where life arises on one planet and is delivered to others. And for planets that are packed close together, this process is quite likely. Outside the solar system, we know of a planetary system called TRAPPIST-1 near a dwarf star located several tens of light years away from us, where there are 7 tightly packed planets, and 3 of them could potentially host life. They have just the right surface temperature and they're Earth size, and they're in a very tight configuration. So in such a system, very similarly to the Earth, Venus, Mars system, you can imagine transfer of life. And more generally, it's also possible for rocks to transfer life in between planetary systems, between stars. Now, this doesn't solve the question of the origins of life, because you still need to produce it on one planet. But an interesting question is, how can you tell that it was transferred from one system to another? And the way to tell is if we go to Venus and scoop the clouds using a probe that goes through the clouds of Venus and we find life there, we can examine whether it looks just like life on Earth. There is no reason why the helicity of the molecules would be the same as those in living organisms on Earth, why the DNA structure would be the same. And if it looks identical, this might be a clue that life was transferred. If it looks very different, it will obviously be a clue that it developed completely independently of life on Earth.
Dr. Avi Loeb, member of the President's Council of Advisors on Science and Technology, founding director of the Black Hole Initiative, Frank B. Baird Jr., professor of science at Harvard University, and author of the book Extraterrestrial, available to pre-order and I think coming out in January of 2021, right?
Yes.
So if somebody wants to connect with you, Avi, maybe they want to get a copy of your book, what's the best way they can do that?
In principle, all the information about me and my research is available on my personal website, which can be found by Googling my name. But if one goes to Amazon, the book is already there.
Sounds good. And thanks again for joining us.
My pleasure.
And find more of my interviews right here or at tonyahall.net. Thanks for watching.